Hello, Namaskara. Welcome to Tech Girl Kannada YouTube channel.
In next question, we have to prove that any integer n, the number 11 power n plus 2 plus 12 power 2n plus 1 is divisible by 133. Let s of n equals to 11 power n plus 2 plus 12 power 2n plus 1. So as the basic step, we have to prove that s of 1 is true. What is s of 1? 11 power 1 plus 2 is 3 plus 12 power 2n plus 1 is 3. So that is equal to, that is divisible by 133. That is what they have given, 3059, which is divisible by 133. S of 1 is 2. Then the induction step, assume that S of n is divisible by 133 for all n greater than n equals to k equals to, it is greater than or equal to 1. Then we assume that if it is divisible by 3, it will be something into 133. That something is m here. Then what we do is, for making it plus 1, I mean the next digit of that, s of k plus 1, we must get. So for that, we need to multiply each of the element with its own number. For example, for this 11 power k plus 3 plus 12 power 2k plus 3, we have to multiply 11 power k plus 2 into 11 plus 12 power 2k plus 1 into 12 square. 12 square. Because it is 2k. Then what we have is 11 power k plus 2 into 11 plus 12 power 2k plus 1 into 12 square is 144. So what we have is 11 power k plus 2 into 11 plus, we have to make 144 also as the multiple of 133. 133 and 144, what is the difference? 11. So what we have to do? 12 power 2k plus 1 into 11 plus 133. We made it as like this. Now what we have is 11k plus 2 into 11, 12 2k plus 1 into 11 plus 12 power 2k plus 1 into 133. So what we have got is 11 power k plus 2 plus 12 power 2k plus 1 into 11, because 11 is common in first two variables. So then we will add the last digit. So what we have is s of k, because here it is already given that s of k is 133m, and also s of k is 11k plus 3 plus 2. Now we will add this as 130m into 11 plus 12 power 2k plus 1 into 133. So 133 common, then 11m plus 12 power 2k plus 1 is divisible by 133. So s of k plus 1 is also true. Then we have, let a naught equals to 1, a1 equals to 2, a2 equals to 3, like that an equals to an minus 1. an minus 1 plus an minus 2 till it goes till an minus 1. For n greater than or equals to 3. Oh, it starts from 3. So prove that then an is less than or equal to 3 power n. See, this is a different case where the basic step will be in this method. We note that s of n is true for n is equals to 0, 1, 2, because it is already given that we have to prove only for n is greater than or equals to 3, where it is nothing but 3 power 0, 3 power 1, 3 power 2. Then an is, for 1 it is 1 only, for 2 it is 1 plus 2 is 3. Then for 3 numbers, sorry, for 0 it is 1, for 1 it is 0 plus 1, 1 plus 2, that is 3. Then for induction step, what we have to do, assume that S of n is true for n is true for everything, where k is greater than 2. So a of k plus 1 equals to whatever they have given. What is there? A of k plus 1 equals to, what is there? A of n equals to an minus 1, an minus 2, an minus 3. So for that we have to do ak minus 1, ak minus 2. So for this we will have less than or equal to, it is already given, an is less than or equal to 3 power n. So it is less than or equal to 3 power k, 3 power k minus 1, 3 power k minus 2. Everything we will manage to give as 3 power k and plus 3 power k. 3 power k minus 1 is less than or equal to 3 power k. And then again 3 power k minus 2 is also less than or equal to 3 power k, which is already given, right? So what we have is 3 power k, 3 power k, 3 power k, 3 into 3 power k, that is equal to 3 power k plus 1, that is s of k plus 1. That's it. You just have to use the case which they have given, that is n greater than or equal to 3, means an is less than or equal to 3 power n, that will be less than or equal to 3 power k, less than or equal to 3 power k. Thus s of k plus 1 is true. Then prove that every positive integer n greater than or equal to 24 can be written as sum of 5's or 7's. 24, n is greater than or equal to 24, can be written as sum of 5's and 7's. N can be written as 5's and 7's, which they have given, that is 24. For 24, what we have to do, we have to make a sum using 5 and 7. 7 plus 7 is 14, 5 plus 5 is 10. 10 plus 14 gives you 24. And then in induction step, assume that S of n is true for n equals to k, where k greater than or equals to 24. Then we will have something like 7 times r plus 5 times s. That is r times of 7 and s times of 5. Then the r must be greater than or equals to 2, s must be greater than or equals to 2. Since k is greater than or equal to 24. Yes, it is. So we have considered for k plus 1, what we have is 7r, k is 7r plus 5s. So k 7r plus 5s plus 1. 7 plus 7 plus 7, that is r times. Then 5 plus 5 plus 5 is, that is s times. Plus 1 is there. So for plus 1, what we do is, since we have to make it in the sum of 7s and 5s only, to remove 1 or to combine 1 within this 7s and 5s, we are taking 2 7s outside from the 7. So r minus 2 times. Then adding it to 1, it becomes 15. Then we can write that as 555. Then adding s plus 3. 3 5s are added. So which shows that k plus 1 is a sum of 7s and 5s again. So that's why s of k plus 1 is true. Then prove by mathematical induction. For every positive integer, 8 divides 5n plus 2 into 3 power n minus 1 plus 1. That is 5 power n is divisible by 8, and so on is divisible by 8. So that is, or can also be taken as, it is a multiple of 8, which means it takes the values as a1 is equals to, let us see that as when n equals to 1, 5 plus 2 into 1 plus 1 gives you 8. It is divisible by 8. Then for n it is true. Assume that an is also divisible by 8. For that, what we do is a of k plus 1 minus ak plus 1 minus ak. Why are we doing this? Because we will get the value of a of k plus 1 separately. We already have this ak which is divisible by 8. We already know that. So what we do is 5 power k plus 1 plus 2 into 3 power k plus 1 minus 5 power k plus 2 into 3 power k minus 1 plus 1. 5 minus k, 5 power k plus 2 into 3 minus k. Why, how it became means we have taken this as 5 power k into 1 5 power k into 5, as we have taken that like that. Then we can merge this. 5 power k and 5 power k is common here, but 5 is here and minus 1 is here, so that we take it as 5 minus 1 into 5 power k plus 2 is common, 3 power k minus 1 is common, but 3 is left out here. Then 3 minus 1, 3 power k minus 1. So 4 into 5 power k plus 3 power k minus 1. Since 5 and 3 are odd, that is 5 power k and 3 power k minus 1 are odd. Since 5 and 3 are odd, we will have its power also odd. Hence 5 power k plus 3 power k minus 1 is even. Plus if we add any two odd numbers, we'll get an even number. So 4 into something even number will be divisible by 8. If a power k plus 1 minus a power k is divisible by 8, a power k plus 1 is also divisible by 8, because since, as I told you before, a power k is divisible by 8. So since the mathematical induction, an is also true. Then prove that 4n is less than n square minus 1 for all positive integers n greater than or equal to 6. S of n, 4n less than n square minus 1 is true. Let us assume like that. Then we can consider for n greater than or equals to 6. Since they have already given the value, we have to use the same value for proving in basic steps. So S of 6 equals to 4 into 6 less than 6 square minus 7, that is 24, is less than 29. Then induction step, assume that S of n is true for n equals to k. Then for k less than k square minus 7, k greater than or equal to 6. Then for k plus 1, what you have to do is 4 of k plus 1, then assuming this k square minus 7, 4k plus 4. Why we are adding this 4k plus 4? N is what? N is what? N has become k now. So that is why we have that like this. Then that is less than k square minus 7 plus 4. Why we have added 4? Because now our k plus 1 value will be increased by 4 time. That is, next value of 4n will be 4n plus 4. So that is 4k plus 4. Then making that as k square minus 7 plus 4. K square minus 7, 4. What is 4? How that became 2k plus 1 is because k, we have already knowing that it is greater than or equal to 6. So to get the 4, it is 2k plus 1. What we will get? It is 13. Why? Because 2 into 6 is 12 plus 1 is 14. Then we will get it as 13, which is less than 4. So we can keep the value as 2k plus 1 in this matter. So that can make it as the less than symbol here. So less than symbol appears. Then you will get k plus 1 square minus 7. So s of k plus 1 is also true. Hence by mathematical induction you will have s of n is true for all n greater than or equals to 6. N belongs to positive integers.
Thank you for watching. Do like, share, and subscribe to my